a copy of this video, a link to a copy of this video on YouTube. You'll get a link to these materials here, and you'll also get information on how to get access to the software we're going to show you. So please sign in up front. As long as you're an ISU person, we can provide free access to the ArcGIS Pro software and online trainings to help you extend your learning beyond this without having to register for a course in GIS, right? Because we all need extra things to do in our spare time. So we're going to start off just briefly today to demonstrating the ArcGIS Pro interface. Then we're going to move on to kind of making a map as part of that ArcGIS interface using some streaming online data. Yeah, come on in. Don't forget to sign in, though, up here. Yeah, sorry. And then how to kind of export a map. You could stick it in a PowerPoint presentation or in a journal article, right? And some things to think about there. Then we'll move on to actually creating data and getting kind of map data into ArcGIS Pro. How to make your own GIS data with attributes attached to it. These attributes are like things about a specific location, point line, or area feature that might be out there. Then we're going to look at some of the tools that are baked into ArcGIS, more in a kind of introductory fashion. Here are where you would find tools that do this, rather than let's run every single one of these tools, because we don't have, in a 2-hour period, enough time to demo every single tool, because there are literally probably between 10 and 20,000 different tools to interact with spatial data in some way within this software. But we'll show you where certain ready-to-use tools are and where other tools that form building blocks of very complicated analysis chains can be found. Right? And then finally, or not finally, next step, and each of these will be maybe about 20 minutes, we're hoping. Next step is finding data and where you can learn more about how to use this software. You can always take a GIS class within the department here. Dr. Badijo teaches them, I teach them, Dr. Obermeyer teaches them, Dr. Berta and Dr. Wang teach geospatial information courses as well in the remote sensing side of things, which is a very similar parallel technology, air photograph analysis, satellite image analysis, etc. So there's a whole suite, probably almost 10 or even 12 courses that deal with geographic information systems or remote sensing here at ISU. But if you don't want to, audit or take a course, there are other self-guided training opportunities that you'll get access to. And then finally, we'll end with some examples of GIS projects. Dr. Badijo has brought a couple that he's been working on, and I could talk a little bit about some of the things that I've done as well. Or some of you I know have used GIS before, and maybe you're just getting used to the new interface in ArcGIS Pro. Some of you, we welcome your input too. All right? Any questions about kind of the format and what we plan to do? All right, again, if you want to follow along, you can. The data I'm going to be working with can be downloaded at this address. You will have to sign in with your ISU credentials. And with that, and you probably don't have ArcGIS Pro on your own computer. The lab computer's here. You just sign in with your ISU credentials and you can get access. All right, so to dig right in, ArcGIS Pro is very different, at least in appearance, from ArcGIS Desktop, or it used to be called ArcMap, and even before ArcView. So if you've used GIS before, you've probably used this piece of software over here on the left-hand side, ArcMap, some version of it, and it might have been called ArcView. For those of you who've been doing this for like 20 years, like me and some of the other faculty in the department, you might know other Arc software that we don't use anymore. It's kind of out of date, right? ArcGIS Pro has some advantages over ArcGIS Desktop. It's a 64-bit piece of software, which means it can address and process data more quickly. It can use multiple computer processing cores, so it's a lot more efficient at processing data. That said, it does have some somewhat stringent requirements. I'm going to fire up ArcGIS Pro here. The requirements include at least 8 gigabytes of RAM on your computer, a multi-core processor, and it's good to have some kind of discrete graphics card, right? Those are, I think I would consider the minimum requirements. It's better to have 16 or even 32 gigabytes of RAM, to be honest with you. I have 32 gigabytes of RAM in my computer, which I doubled on my own price, just because 16 was not enough to be efficient for me. It's good to have more. RAM seems to be the big choke point, but you can run it effectively with 8 gigs. If you're brave, you can try it with 4. It will run. You just might get frustrated.
Also, ArcGIS Pro it works well or better, I would say, with 3D data. So if you have 3D data or you're going to be working with that, I would definitely tend towards this one. But then at that point, 32 gigabytes of RAM is probably required.
Probably required, yeah. This lab is, by the way, open during business hours when there aren't classes in it. So if you have a need to have some more hefty processing power but don't want to, insist OIT upgrades your computer, or they say no, you can come here and use these resources when we don't have class. I haven't made a schedule for the room yet. I usually post one on the door so people know when classes generally meet. I just haven't gotten around to it this week. When you first start up ArcGIS Pro, you're presented, unless you tell it to never show this again, you're presented with a kind of load screen, and it gives you a list of recent projects if you have any. In this case, it's a lab computer. It gets wiped. We don't have any new projects. And some templates for what you might want to work with, and then an ability to open other types of projects, right? For the most part, when you interact with ArcGIS Pro, you will either be creating a new map, or if you're doing 3D stuff, it might be global or local scenes, right? A map, or you might start without a template. Now the difference between these two things is a map will create an entire project folder complete with data storage databases and everything else that you might need to enact a full-fledged project, whereas starting without a template will not create all these file structures in your documents folder. So it's kind of up to you. If you're creating a project and working on it long-term, you might want to create a map and go from there. A lot of times when I'm doing demonstrations in class, I don't really need to save it later on, so I start without a template and go from there. Right? For this, I'll just for the sake of things, we'll start a new project here. It'll ask you to name your project. I'm going to call it Don't Crash, Do Not Crash, and it'll ask where you want to save it. As a faculty member who teaches GIS, one of the things that's always frustrating is that students, and actually to a great increasing degree, many faculty even and staff, are used to clicking download and being able to click in some lists and have it open. Well, with GIS data, you have to be a lot more on top of where your files are stored and where they're going and where you're saving them to. So just note that when you create a new project by default, it's going to go in your documents folder in a folder called ArcGIS Projects. You can change that, but file management is a skill that will be rewarded significantly when you're doing GIS work. So I'm going to go ahead and click OK. Another thing to point out, GIS projects don't like spaces. Spaces, underscores, and dashes, try to avoid them in your GIS work. They will just create headaches later on, especially with some of the older tools. And when I say older, I'm not being negative. They just were developed during a time when spaces weren't even allowed in computer file work on Windows, right? When you create a new project, the entire view will change pretty significantly. So ArcGIS Pro follows along more with a Microsoft Office model of a user interface rather than kind of the older version of Microsoft Office, right? So it's got the ribbon at the top where you can find various things. This ribbon will change depending on what you have selected in your work view, okay? For example, if you click on a certain type of data, a new tab might pop up over here, right? So you have to be aware of what you're working with, what you have selected in certain parts of the interface might change how you interact with the interface. So anyway, the parts of this window, there are 4 main parts I want to point out. The first one is, of course, the map area. So this is going to be wherever your data exists. In the old Arc desktop or ArcMap, this would be called the data view. So if you add data to your project and it's spatial data, not just a table, it will display here, right, in this map view. And you can interact with this map view using, you guessed it, the map tab over here, which will allow you to use various tools, including zooming out to a full extent or going back to where you were. Sort of almost like a web browser, right? Right now, the data that's showing up are actually just streaming over the internet, a world base map, right? Which is kind of a nice feature. when you open a blank project, you already have geographic data to help you identify what you're looking at. The other area, excuse me, the next most important user interface item in ArcGIS Pro is the Contents tab, I would say, although some people might say the ribbon. But the Contents tab is very important, and it has various different views here. When you add data to your project, which we'll get to in a moment, the data will show up here, and whatever order is displaying here, in general, there are some exceptions to that, whatever order these items are displaying will be the order they're drawn. So think about it this way. If I have a piece of data that covers Terre Haute, Indiana, and I add it to my view, but then I place it below the world topographic map, that would be like trying to read this piece of paper through this, right? I'm covering it up with the eraser. I can't see it. I have to change the order by dragging and dropping in this area, right? In the contents pane. Does that make sense? Yeah, so what you see is sort of what you get, top, bottom, right? The next kind of important, oh, and I should mention this, you can list by sources where the data is coming from, whether you can select the data, whether you can edit the data, etc. Right? There are other options here, but for a crash course here, let's just keep it with list by drawing order, which will show you what's on top of what in the list. Any questions so far? Okay. Yeah, no? Okay. So the next important part of this, I mentioned the ribbon already. I mentioned also the ribbon is contextual. So you'll notice right now I have World Hillshade selected. I now have a tab that says Appearance there. If I want to, for example, make the world topographic map look a little different or be more or less transparent, right? I can adjust it in this Appearance tab. I can also, swipe data back and forth to see what's underneath to make direct comparisons, which can be very helpful. I'll show you more about that in a moment. The ribbon has various tabs, which we'll go through in more detail in a moment. And it is one place where you can find some tools to work with in ArcGIS Pro. Finally, another tab that's quite useful but a little bit complicated is this, or this pane, I guess you should call it, over here. This pane has a lot of different functionality, and as you interact with ArcGIS, more panes might pop into this box. I could make a really bad pun about panes and how much of a pain it is to deal with 17 different tabs within this pane. So there is a little bit of management that might have to happen at some point. But I'll refrain from too many bad puns. I am an aging father after all, so it's part of my right, I guess. I don't know. You should note that right now we're looking at a geoprocessing pane, but there's also a pane here for catalog. Okay? And you can see catalog, Deb, right? I'll talk more about catalog in a moment because there are multiple different ways to interact. Well, I guess let's talk about catalog briefly right now. So catalog can exist in a pane or it can be a window here in the middle, right? Sort of depends on what you want to use, what your task at hand is. If you want to make a little change or do something really quick, you might interact with the catalog over here. The catalog will just show you all your spatial and aspatial data that ArcGIS Pro can read, all in one place, along with the tools that you may have loaded into your project, etc. It's kind of like a filing cabinet for all your stuff in this project, right? Excuse me. It'll also show you your history in case you ran a tool and you want to see what you did. You can go back and actually double click on the tool. We'll show you this in a little while if I remember. You can double click on it. It'll reopen the tool that you ran and actually show you all the parameters, all the things that you put in that tool, all the adjustments you made to the settings, which is really helpful if you do something and then come back to it in a couple days and forget what you did, which is easy to do if you're not taking copious notes on your analysis steps, right? Within the project, you might notice there are folders here. We can add other folders, which I'm going to do at this time because I have the data that I downloaded from this URL here in a folder on my D drive. Which one is it? Hold on. No, not Steve. Called GIS Workshop. So I'm going to add that right here. And there are 3 data sets that we're going to work with in a few moments here. Right? So if you want to access things easily, you can add them to your folders in the process that I just did. You right-click here, go to Add Folder. You can access local data, right? And then it's as simple as dragging and dropping here if you want to add it. Or you can use the Add Data button here on the Map tab on the ribbon.
I just want to say right at this point, this is usually the place where people get lost on how to start using data they may have downloaded or that data that somebody else had given to them, a colleague. But it's just as simple as right-clicking on that folder, underneath that Folders tab, adding that connection, and then you can start pulling those data.
Yeah, it's a good point, because I mentioned file management before. It is almost always the breaking point for a new GIS user. Where's my stuff? How do I add it in there? So knowing what folder your data are stored in, even if it's just your downloads folder, is important. And another thing to note is after we have started a project, it's good, just like back in the day when Microsoft Word didn't autosave. Save your work. There's a quick save button up here. Once you save your project, these folder connections will remain. With a caveat, if you have a folder connection to an external drive, there's a 60% chance the next time you put that external drive in your computer and want to do GIS, it will change the drive letter on you. So it used to be D, now it's F. Inexplicable, guaranteed every time it's going to mess you up. At that point, you might need to reconnect or fix the connection, which you can usually do by right-clicking here or adding the data to your thing and then changing the source, which I'll show you how to do. Deb.
So, Steve, are we supposed to be able to follow along with you right now, looking at the same data?
If you downloaded the data from here, and then you would add your folder you downloaded it to, and then you can follow along if you want. But in case you missed it, I will send a video of this out after I upload it to YouTube, probably tonight, along with invitations for everybody to get access to the software and training, etc. All right, so you want to, yeah, Jim.
Is that the technical? Are you recording this right now?
I am recording this right now. So your voices are on it. If you don't want to be heard, raise your hand and be like, pause it, and I will. Okay, who wants to see how you make a map real quick? Yeah, me too. So you can make a map with your own data, but Esri now, the software vendor, has a lot of hosted data that you have access to if you have a valid license. And so for classes in particular, this is actually a really useful way to allow students to interact with real up-to-date data without having to deal with as much of the file management stuff that often trips them up. So within the map tab here, we have our map open, and we can always, by the way, add a second map or third map or 15th map here in the insert tab by clicking new map, right? But let's just work with one to keep it simple. You can change the base map, so that's the stuff that's in the background. Right now we have a combination of a hill shade, which is kind of a 3D elevation shading display, and a topographic map. But there are a whole bunch of different cartographic or analytical backgrounds that you can use, including up-to-date imagery, street maps. You can do dark gray canvas if what you're showing is actually not really a physical feature maybe, but dot map or an intensity of some kind. All the way down to oceans for if you're showing phenomena in oceans, etc. There's quite a lot of them, and it's quite easy just to change the background by switching. So now we're on a National Geographic style background. If we zoom in, it's quite similar to a National Geographic style wall map, right? But in addition to this, we can add data from a variety of sources. Most of the time in this Add Data menu, and I access the drop-down part by clicking at the bottom of the button where there's an arrow. Most of the time, just adding data to the map will be sufficient. And so I'm going to do that, and it'll bring up a pretty standard dialog box, right? Pretty similar to what you see in a lot of programs. I can access my data by going into folders or even going down here to computer and browsing through the file structure, on my C drive or D drive, etc. But what I wanted to show you here and give you a quick demo of how to make a quick map is the living atlas features that stream from the internet. So the living atlas features, some of them are quite complex, but in this case, we can make a very quick map using census data if we want. Right? If you look, we have a whole bunch of stuff: wildfire activity in the U.S., terrain, federal lands, all kinds of stuff. Let's see what else we can find. Poverty ratio, forest type, right? NDVI, which is an index of vegetation health. Some of these are world, and some of them are focused on the U.S. only. Traffic counts, terrain, all kinds of stuff. Let's do USA populated places. So it is streaming over the internet. It'll take it a little while to download, but eventually it'll download and it should display. Let me zoom in a little bit so it has less to draw. Yeah.
When I clicked on the swipe earlier, I'm stuck on that now. Every time I click, it just swipes the...
Yeah, same with me, right? So you see this? I'm on the swipe. So you can either go to the Appearance tab and click on Swipe again, or it's probably better just to go back to Map and click Explore. Okay, so first crash of the crash course. Notice nothing's showing. In this case, I have to log in with my ESRI account for them to make sure that I have rights to access this living atlas data. So this will be something that will be fixed when you get your own login later today or tomorrow when I get a chance to send it all out. But what you would do in this case is sign in, and I'll sign in with my information. I would just share mine with you, except that then you could revoke all the licenses that exist at Indiana State University, or do something that wouldn't be good for everybody. Here we go. So sorry about this, but you'll be able to do it yourself in the future. Maybe. Here, let me try adding it again. Could be, too, we're all clogging up the local internet. Come sit down. All right. There we go. Some of these hosted layers must draw at certain scales and not at others. Maybe I'll try a different one. Of course, this is the one thing I didn't test. Here, generalized federal lands. Let's see what comes up. Okay, here we go. So we have our federal lands map. These are always, pardon me, but I always think these are fairly ugly. We can change our federal lands colors here if we want to by clicking on the layer and right-clicking on it, and going to, usually there'll be a symbology tab here, but because these are streaming, I can't make that change, actually. But let's say that I'm very happy with this map right here. I teach cartography. This is shameful. I'm very sorry. But let's say that I like this, and I want to make a map. But a map isn't just what we see on the screen. It is what we see on the screen, of course, but also a legend, a scale bar, a title, maybe a north arrow, right? All these things need to be on there. So to make a map that we could maybe export for use in a PowerPoint, or a presentation of some kind, a journal article, we actually have to insert a new layout, right? That's in the Insert tab. Here's a new layout. And we have to choose what page size and what page orientation you want to pick.
Can I interject here?
Yes.
Anybody who is a user of 10.5 or something like that in ArcMap, this is the completely different part, and this is where you could easily get lost. So just putting that out there. If you're used to the other way, this is a different method of actually creating a layout and exporting it out.
Right, in ArcMap, it was called Layout View, and you got to it with the little teeny button down there on the bottom left-hand side between the contents pane and the sliding bar,
Yeah.
right? Half the people in the room are like, what? I recommend when you're creating a layout for digital purposes that you actually err on the side of higher resolution, larger size, which sounds weird, but storage space is fairly cheap. The one exception might be if you're putting this on the web, right? But storage space is pretty cheap. You can always resample or scale down or shrink an image. It's tougher to take a small image and make it bigger, right? It's not going to look as good. So often if I'm making something that's going to go in a conference presentation, I pick something like a tabloid size layout, either landscape or portrait, and that's how I work, right? And that way when I export it to a graphics format like a JPEG or PNG or a PDF, I can resize it if I need to, right? Okay, so now what we are looking at is actually a page, and it's pretty close to how this page will look when we send it to the printer, right? Or when we export it as a PDF or graphics format. So the first step is, well, okay, we have our layout. What do we put? How do we get our map in here, right? Well, in our new layout here, we can add what's called a map frame. And you'll notice I have a default extent, or I have what I'm currently showing in my map over here, which is a 1 to 6.5 million scale map. Notice it's down here, 1.1 unit on the map equals 6.5 some odd million units on the ground. This is what we call a representative fraction in geography. You're probably all familiar with it, but it's a unitless measure of scale. So you can make one pencil length measurement on the map equals that many pencils on the ground, etc. Right? So I can either add a frame at that scale, which I just click where I want it to go, and that'll be the bottom. Or I can create an extent of any size, and it'll place the unzoomed map in there, right? But I don't want to do that at this point. I want to make a nice map of my own, right? So I'm going to zoom that out. It's going to redraw. Maybe now I have a little bit more area. I have a higher, a finer scale here by about 1 million, right? And now I want to make a quick layout. I'm not going to be perfect here in the interest of time, but maps, like I mentioned before, typically have a legend, so we know what each one of these colors means, right? They have a scale bar, so we know approximately what size this unknown area really is, and they might have a title so that we can understand what we're seeing on the map. So the first thing, and they might have a north arrow too. It sort of depends on scale and preference. It's a fight we get into in cartography often, like, you said I should have a north arrow, except for when you shouldn't. To add a legend, we just, in the Insert tab here, we click on Legend, and we draw a box about where we want that legend to be. And ArcGIS Pro will place a totally unacceptable, terrible legend in there. Right? So what are some problems with this legend? One, we can see all the way through everything, so some of the features on the map are actually making it hard to read the legend, and vice versa. Two, it's just repeating the same thing over and over again, right? So we'd prefer it just to say one thing. National map, federal lands, that's descriptive. We could guess what it is, but it's not really suitable for, an audience. And then USA _ federal _ lands is also sort of like, well, it sort of says that below. That's not very pretty. So we can interact with this in a number of ways, mainly by double-clicking or right-clicking and going to Properties. We can change a number of things about our legend, including what legend items are in there and whether we want all of these items to be displayed. So right now we have layer name and its label displayed. So if we were to underscore or turn that off, we suddenly get rid of the redundant information, right? Maybe we want to remove national map federal lands. Let's see, where can we get that? Show properties. We don't want the layer name here. And then at this stage we have a group layer name, which corresponds to this. So one of the ways I can change this would be just to rename this in my table of contents. Federal Lands USA. And as I switch back over to my layout, it will now mirror that, right? So you've got a couple places you can change what's in the legend, or you can move back over to your table of contents and rename these things, right? Okay, so now I might want to fix the fact that my legend is larger than it needs to be, right? So I can resize it like that. I can position it in a suitable place. And now maybe I want it to have a white background so I can read things better. In this case, I'm going to choose to display a background in white, right? Oh no, my legend has a box that's bigger than the white background. But if I were to do something like this, I would start running afoul of something that we talk about in our cartography classes called like visual tension, right? This edge is far too close to the bottom. Now for a quick and dirty map, it's not a problem. But to fix it, I'll just point out, as a way of introducing some other tools here, we would perhaps consider inserting some, where is it here? Inserting a rectangle? No, not a text rectangle, one of these. And I am going to draw out a box. Hold on. Let me get this out of the way. So I drew my rectangle. Let me see here, should be there. Let me make another one. Rectangle, there we go. My rectangle is probably currently empty. It's a black outline. So what I'm going to do is, yeah, it's a black outline right now. So I'm going to change the, let's see here. The window's too small for me to see everything. Sorry about that. I've been keeping it up there so you can see if you're in the back. But essentially I'm going to change not the color, but the fill to be a solid fill, and to not be clear, I want it to be white. And if I hit apply here, now my stuff's covered up. Oh no. Right? But what I can do is move it in order behind the legend in my contents tab, and now I have a nice white background that's blocking the rest of the map from coming through. Right? Just a quick, this is a lot like working with layers in Adobe Illustrator or something like that. Right? Okay, now I want to add maybe a title and a scale bar and a north arrow. Well, as you can see, there's a scale bar button. I can click that there, draw out how long I want it to be. Terrible because the font is so tiny on my big map. I can come here to format and actually change the font of various aspects using these contextual menus. All right. In this case, keep in mind that your scale bar has not only text for the text, the number of miles, but it might have sizes of tick marks, etc., all of which you have to mess with here. I'll point out that different scale bar designs are available here as well. I'm not going to go through tweaking every single one of those, but you've got the location to go to insert that. And then finally, maybe a north arrow, same kind of thing. I'm going to tell you right now that the options for north arrows available in all ESRI products are awful and ugly, although that's my own personal opinion. Some people disagree. But I think they're all terrible, and I would make my own if I were you. Except if you're in a hurry and don't want to. And then finally, you can insert text, including things like a title with various formatting, using inserting either a symbol here or inserting dynamic text, which would update according to the properties of your project, or even a text box like this one, which I can draw out. My ugly park, federal lands, right? Map. Notice that the default text size here is pretty small. In this case, I can change the format here. 12 points, that's not a very good title size. Maybe I make it bigger, right? Whatever. And then you can position this where you want it to go. Let's pretend that my ugly map is ready, right? How now do I take this beautiful forest map, federal lands map, and turn it into a product that I can put in my PowerPoint presentation and not have it look like garbage? Well, in ArcGIS Pro, you share data, whether it's an export or actually the data itself, here in the Share tab. And so I'm actually in my layout view, I click on the Share tab, and I have an Export Layout button. You can also print from this tab, right? In this case, I click Export Layout. A dialog box will come up. A couple things to pay attention to, okay? One, you can save as a variety of file types, some of which will go right into something like PowerPoint or Word document, no problem. Others, like scalable vector graphic, SVG, will not, right? They're not really, I mean, they will a little bit, but they're not really designed for desktop publishing or PowerPoint. Others are going to yield, they're largely uncompressed, so they're going to be large file sizes, but they might be what your journal wants when you look at TIFF file. And then PDFs are a good way to share maps with collaborators because they're self-contained and usually have a reasonable file size. So let's say I want to make a PNG file to put in my PowerPoint presentation. There are two other options you should be aware of here. One is your dots per inch, your screen resolution. If you're putting this in a PowerPoint presentation, 96 DPI, 120 DPI might be okay, depending on the resolution of the projector. I would just say put it up at 160 or so for on-screen, just to be safe. For publication, it's going to be 300 DPI or 600 DPI, right, is what the publisher is going to want. Probably 600 DPI. Another option here is click to graphics extent. This is up to you. If you do not click this button, the export will include all this white space around the edge. You might want that. You might not want that. It's kind of up to you. If you click that box, it will clip it only to the very edge of the map, and you won't have all that white space around the edge. All right? Okay, so let's say I save this at 300 DPI, and I clip to graphics extent. I saved it to my desktop, I think. Practicing bad file management skills. All right. And because I said 300 DPI, it's fairly high resolution. It'll take it a moment. And if I look at my layout here, here's my layout as it looks on my desktop. So if you notice, I scroll in and it has fairly decent resolution at high levels of zoom, but it's not perfect. Right? Of course, it's far from a perfect map overall anyway. All right.
Can I say a couple of things?
Please.
So users in the past, you may have noticed export was the word they used to actually get those maps out. Nowadays, it's turning into share because of the interactivity between this software and a lot of the online tools as well. So it's not just sharing and making a static map, but also sharing with some sort of online service. And then the other thing, would you mind showing them how to activate the frame so that you can zoom and move in and out? Because that'll be frustrating for anybody who's making a basic map.
Even somebody who uses this software a lot, it's frustrating. All right, so if you're working on your layout here in the layout view, and you're like, wait a second, I don't want to show this part of the US. I want this view to be zoomed over to the west a little bit more. Well, if I click on it in here and I move to the west, it's like I'm holding the map in front of me and going like this, right? I'm moving the map rather than the data. So to move the data, you have to go to the Layout tab here and click Activate. That's going to change your view back to the layout, the map frame that's in the layout, and I can interact with these data, moving the data rather than the page.
And here's where you can zoom in and out and move back and forth to adjust it just as you want it for whatever publication.
Yep. When I'm done with that, I have to go back over here to say, it says Activated Map Frame, click on Layout and say Close Activation.
Shortcut would be in the top left of the map frame. It says Layout, click on the blue hyperlink.
And go back. Yep.
I found that luckily
earlier. I learned something today. So keep these things in mind. It's a little bit different than the old way. If you've never used the older software, this is probably one of the least intuitive aspects of making a map, was that switching between the data frame, moving the data around and moving the page around, right? Any questions about that kind of quick and dirty, very dirty, ugly demonstration? Okay. So you might be thinking, all right, this is great. You can look at some random data set and make a lousy map of it and then export it as a PNG file. Well, actually, most of the time, you're hopefully going to be working with your own data, and you might be wondering, how do I get data into this monstrous piece of software, right? So using an example from my own research in the eastern Brazilian Amazon, I wanted to show you how you can take an old map, turn it into geospatial data, and then maybe do a little bit of analysis on it really quick. And so by doing this, the goal is that you'll learn how to take an image and turn it into one that's spatially correct, right? So you're taking you could literally go and find a map on Google image search and turn it into a valid geospatial data set, a picture, but it'd be rectified in space. You're going to learn how to create new geographic data sets and populate them with features and attributes. So we're into item 2 finally in this section. So we're only running half speed of what I was hoping. But that's okay. If we only get through overview of tools or something, we'll be fine. So the first step here in a new project like this is I'm going to create a new map. You'll notice I selected, I'm not making a new project. I'm just creating a new map or whatever. I'm going to insert one of the data sets that you can access here, and that's in my folders. Oh yeah, I have to connect to a folder again using catalog. Hold on. Catalog, folders, because I created a new project for this. GIS workshop. Okay. So I could add data through here. I'm just going to drag over map to rectify. So this is a fairly high resolution scanned map of the eastern Brazilian Amazon and some property boundaries. We'll explore it in a minute. When you add certain raster or image data sets, you might receive this message. It says the raster data source does not have pyramids or contains insufficient pyramids. You might be wondering, why are we talking about Mesoamerican archaeology, right? Pyramids allow for rapid display at varying resolutions. It's just a data access artifact to allow the software to draw the image quickly, so you don't wait so long. Building pyramids may take a few moments. Would you like to build pyramids? Usually you want to say yes, right? In this case, I'm going to say yes, because we'll be zooming in and out. So I'm going to say yes. Pyramids will draw. Don't be alarmed by that error message, in other words. It's just saying you might want to do this, but we're not going to do it without asking. Notice you could have checked a box. Do this always, right? So I've added my data. Where is it? This is a common problem. In the Contents tab here, we can always find our data set, right-click on it, and go to Zoom to Layer. And it will bring me to the most popular place in the Atlantic Ocean. Where are we? 0 degrees latitude, 0 degrees longitude, right? Because my image has no spatial reference at all. So it's at the origin point of our latitude and longitude spatial reference system, right? So what I need to do, we'll explore the data real quick, and then I've got to show you how to make these data fit on the right location on Earth, okay? So this is a scanned map that I got from a government agency in Brazil. It covers the central and southeastern region of the state of Pará in the eastern Brazilian in the Brazilian Amazon at a 1 to 500,000 scale. It has data on it that go from 1970 to 1982. Actually, some that go back as far as 1957. And the area I'm most interested in is this area around the city of Marabá. And what you'll notice is on this map we have some real-world features that we might be able to relate to other real-world features to make this scanned paper map from the 1980s fit in today's real world, right? So, and this is a common task where you have a paper map and you want to georectify it. It's one of the things that I think many people will end up needing to do at some point. Notice this is scanned at a pretty high resolution so we can find specific features, right? So, but right now I'm at the 0, 0 mark, and where I really need to be is like over here, down here by Marabá, right? So I'm going to do a couple things. One, I'm going to change up my base map to be imagery with labels so that I can see what the real world looks like, including rivers, which are going to be, unfortunately, they change. This is not an optimal georectification, right? Rivers, especially in a place like the Amazon, change continuously, but I'm going to work with what I got, right? I'm going to perhaps set my scale here to 1 to 500,000, to match the scale at which my rectify map is set, right, 1 to 500,000. I'm also going to make sure my map to rectify is on top of my world boundaries, places, and world imagery. All right. So now I want to find a obvious phenomena between these two places. Right? And I'm going to go with a very important historical landmark called the parrot's beak here. Right? You can see it kind of looks like the head of a bird. Right? And I'm going to, here on the imagery tab, choose the georeference function. So georeference just means add spatial information. Right? Link spatial information to this.
I make sure that my history majors that take GIS know this one right here, hitting that georeference button so they can work with those historic maps.
Yeah. So at this point, my view hasn't changed much, except now I have a whole new set of tools here. And what I need to do is add corresponding points between my scanned map and reality, or at least a digital representation of reality, right? So I'm going to find on my scan map, I'm going to select the at 1 to, well, I can't go to 1 to 500 scale here, right, because it's not georeferenced. But at the same level, or at this level, I'm going to pick, add a control point here at the very tip of the beak. Boom. And now I have, at least for the first time, the arduous process of moving myself. Notice I switched to map and switched to explore. Moving myself over to the Brazilian Amazon, finding the parrot's beak, right? Which is right about here, right? Except that I'm at 1 to 168,000 scale. I need to find that same spot at 1 to 500,000. Why am I doing that? Does anybody have an idea? Well, since the map that I'm linking it to is produced at the 1 to 500,000 scale, I cannot get any better in terms of my accuracy than 1 to 500,000 scale. So I don't want to go in and find that very specific point at 1 to 300 scale, for example, because I'm going to be linking it more accurately than actually the map is, right? False accuracy would be the result. So I'm going to pick, switch back to georeference and click on Add Control Points. And I'm going to go ahead and click on the parrot's beak. Oh, darn. Okay. We'll go back and do it again. Let's see. Zoom to layer. Zoom in on the parrot's beak. No, this is actually a good thing because I can show you this feature. So notice before I had to zoom out and zoom back, all that, now I can just go here to map, click back, 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 and I'm at 1 to 500,000 scale at the parrot's beak. Click. Okay, good. Now I have to do it again. And actually, to do a map like this, we would want something between 30 and 120 correspondence points if we could get them. The more the better, right? Let's see. Now let's find another good point. And I'll only do 3 points because that's all that's really needed to do this. I'm going to pick the very historically important in the communist uprising in this part of the Amazon location of Xuebin Wei. It's the town. Again, back, back, back. And now I'm going to zoom out. Darn. I'll have to do this, right? I'm going to turn on my world places and hope that Xuebin Wei is still on there. It's a pretty small place. There it is, okay? 1 to 500,000 scale. Darn. I think this is a slightly outdated version, so I have to go redo it again. Sorry, no, this is super exciting. We'll go Xuebin Wei, map, back, 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 back. Xuebin Wei. Now look what happened. Because we've given it 2 good points, it's starting to correct our image and place it in the actual locations that it is, right? So now we just have the ability to, say, pick a place like And at this point, we probably want to stay at 1 to 500,000 scale because we're in the right vicinity, right? So I'll make sure we stay there. And I'm going to pick, maybe by comparing these two, a little bit of a, let's see here, Bakaba is not a place that they pay attention to. Maybe the edge of this, which is a bad place, again, you want permanent features, but for demonstration's sake, maybe this island right here. So I'm going to go on my map to rectify. I'm going to pick my from point, or my source point, here, and then my to point, which is pretty much the same place, right? Pretty good. Let's see, one more point maybe, and I'll do it down in this zone here at 1 to 500,000 scale. And we can pick, let's see, explore a little bit. We can pick this point, Serra Pelada, which is the world's largest iron mine, right? We'll pick just the central location. Again, I'm not showing you ideal practices, and we can find maybe Serra Pelada is actually here, right? Once we've gotten enough of our correspondence points, we're going to look at a couple things. One, I don't know, Alex, I haven't done auto georeferencing yet. You were saying you had okay luck with it?
Yeah, but you have to have some maps that are very similar.
Yeah.
That'll work.
So
if somebody gave you a JPEG of a map that you want to get into your geodatabase where it's supposed to go, and there's enough detail in that map, you could just place it in there and hit auto georeference and hope for the best.
Right.
And sometimes it works, sometimes it doesn't.
But since this is satellite image to a historical, probably somewhat hand-drawn map, right, we're not going to do that in this case. Ideally, like I said, at least 30 points here. I'm going to go ahead and save as new my georeferenced image, okay? So I'm going to save as new. Why am I saving this as new? Well, if I save it, it'll overwrite my original data with georeference, which isn't so bad, but I want to make sure that I'm keeping my original data in case I totally foul something up later down the line, right? So in here, you'll notice when I click Save as New, a tool called Export Raster came up. So I'm just going to go ahead, and you should look at your coordinate system, etc., what you want to include. In this case, all of the defaults are actually what I want. And at any time, if I'm not sure what I want to put in here, these, let me see, let me try to make it a little bigger. Most of these tools have a little link for help up here. You can click, it'll open up a web browser and show you the detailed documentation for each one of those tools, right? I'll go ahead and click Export, and it'll add my rectified map. I can't save it on this computer in a default folder. I'm going to call it rectified. And when you work with rasters or images, you do have to tell ArcGIS Pro what extension you want to use. Do you want to save it as a TIFF file? Do you want to save it as a JPEG 2000 file? Don't. I've had more trouble with those than I would like to report. Do you want to save it as an AirDAS Imagine image file, which is another image processing software? That's a good one to pick sometimes. Do you want to save it into a geodatabase, which is a type of data that we'll create actually in a moment? So I'm just going to save it as a TIFF file for now, and it will run the geoprocessing and give me an exact copy of this, but now located in the proper place. Good practice when you do this is actually to save your control points as well by exporting them. You should also look at your control point table, which will give you your X and Y residuals and your overall residuals in your correction. Eventually, it'll also give you a root mean square error that tells you how off you are. But in this case, because it's a kind of working example, I don't have enough points for it to calculate that properly. Right? Failed to export. Why? Rectified. TIFF, no compression.
Did you actually hit export again after you?
I might not have. No, it says failed to export. Oh, because it changed back. It's annoying. All right. Save. It keeps defaulting back to this. Anyway, now let's pretend I have this. rectified. At this stage, I have an image, but I have geographic data in the sense that this image is located in space correctly. But what I really like is each one of these is actually a property boundary that I'd like to do some analysis on. So in 1980, it was probably forest, but what was happening there in the year 2000, for example? But right now, I can't really overlay these two things and make measurements about forest cover or anything else, or even the size of this unit, because I just have an image. So what I really want to do is what we call on-screen or heads-up, because you're not looking down at a table, you're looking up at a screen, digitizing on top of this image that I've now located properly in space. The first step to do this is in your catalog pane over here, I need to create an empty data set to put my digitizations into. Right? We call them feature classes. Feature classes can be a variety of things, but the main ones are points, lines, or polygons. Right? We also have things like annotations. You can have text that's fixed in space. But again, that's something maybe you would learn in a GIS class with one of the faculty here in the department that I mentioned earlier, or through an online training. There are a couple that talk about annotations. So
you may have to hit just the general save button until you start creating features anyway. I don't want it to load long.
All right, that's fine. Let me see, just make sure I've got everything done here. Yeah, okay. Now I want to make a new, what I want to do is make that empty data set. In this case, the empty data set is going to be a file geodatabase. File geodatabases are probably, at this stage, the most flexible and beginning to be the most widely used type of geographic data in the ESRI environment. They can also be opened by other software. They are proprietary, meaning that they are an ESRI product or data format, but they're widely used and they are much preferred to the older shapefile. Now, they're much preferred for a variety of reasons. If you are interested in the specifics, I'm happy to send some reading material or have a very, very intellectually stimulating conversation over a cup of coffee about data formats. But essentially, a geodatabase is going to be more portable, allow for larger file formats, and have features related to spatial relationships that you can encode in the data, among other benefits. But there are some drawbacks to a feature or to a file geodatabase. The main one being that you have to interact with a file geodatabase in a GIS software environment. I'm going to show you why I say that in a minute, but it's another failure point sometimes with new GIS users. So I'm going to create my file geodatabase. It's going to take it a minute. It'll add in here, sort of like you're creating a new file in Explorer. It'll add in a thing that I can rename. I'm going to make it so that I'm not dropping the .gdb at the end, and we'll call this example, right? So here in the catalog, it looks like its own standalone piece of information, and it is. But if we were to interact with these data in Windows, don't do this, please. It looks like a file folder with a .gdb in the extension. So while my map to rectify, right, is a normal TIFF file, and some of these other data sets appear to be something called a disk image file, which isn't actually what they are. Windows thinks that's what they are. In this case, it looks like a folder. But if we open this up and do something like say, okay, here's a bunch of stuff in here. I want to add my map to my geodatabase, and we drag and drop it in there. Not only will you break your geodatabase, you may break the data that you added to it that way. Or at least you'll lose it because you'll forget it's in there, all right? Instead, we need to interact with this geodatabase here in the catalog or in the actual catalog view, which is another tab that you can open up in here. Okay. In this case, my example geodatabase, I can add my map here by importing or copying a raster. I can go copy and paste it in there. But really what I want to put in here is the digitized polygons that I'm about to add. So to do that, my geodatabase now is empty. I want to right click and go New Feature Class. So feature class is what I said before, point, line, polygon, there's a couple other things. There are other things that you can add into a geodatabase. I'll go over them briefly. A feature data set, you can think of this as a folder that you can place feature classes into, right? The cool thing about that is if you have 6 feature classes in a feature data set and you want to add them all to your map at once, you can just add the feature data set, boom, they all pop in. A table is just that. It's like an Excel spreadsheet, except that you can't click and work around in it as easily as you could in Microsoft Excel. But indeed, a table could come from a Microsoft Excel spreadsheet or a CSV file. A view would be something like this. We can't create one of those. We would save it to there. A relationship class is a relationship between features or tables. Again, this is kind of somewhat down the road. If you're working with large tables and large data sets, you might save one of those in there. A raster data set is just going to be an image similar to this map in the background. And a mosaic data set is essentially an assemblage of rasters that line up right next to each other, like a tile mosaic might on the floor, except that there's no spaces between, hopefully, right? In this case, we want to create a feature class. When we click on that, we come up with a nice little wizard here. We're going to name it. I'll call it properties, right? And I have to choose what I want to put into this feature class. In this case, I want it to be a polygon. Notice there are, 7 different options there, right? Points, lines, and polygons are the most frequently used. You also have a chance to include M values and Z values. Without getting into the gory details, M values are only needed for routing, however you want to say it. So this would be like, logistics or navigation data sets. No, we're not doing that here. Better to not include it, to be honest, because some tools will erroneously read data in an M value field within that feature class. Same thing with Z values, which are elevation. I had a nice 45-minute conversation during one class last semester about Z values. Students, it's not that they didn't believe me, but they were like, why? Why would you say turn this off when in fact we have elevation data in there? And I'm like, well, because you can't treat Z values, if you make them this way, as a normal attribute. Z is elevation or altitude, right? It constrains how you can use the data a little bit. Anyway, too much detail there. We can leave that off. I'll just leave it in for now. Then we can have fields. In this case, fields are the attributes you want to add to your feature classes or your polygons. In this case, I might want the farm name, right? Because these are actually farms, right? The property name. If I happen to have it, I might want to know about owner name as well. Put that in there, right? And then for each one of these attributes, I have to choose the data format. You can store things, of course, as text or date, right? You can store things in various data types, integers, both short and long format, double, which is a floating point, but it's not a full floating point, and float, right? If you're not familiar with what these terms are, let's summarize it really quickly. Text, date, number without a decimal point, bigger number without a decimal point, number with decimal points. To talk about it in terms of data storage, some, not much, a little bit, a lot, right? In terms of how much space it takes on your computer. When I say a lot, we're not talking about an insane amount, right? We're just saying a lot more than double what an integer would be. In this case, both for farm name and owner name, I'm going to save text because it's just the words, right? Next, I have to choose my spatial reference. Again, we could spend an entire semester talking about spatial reference, which includes coordinate system projection, essentially how you take a round Earth or a spheroid Earth and make it flat on a screen, right? And also datum or origin point and other information about that coordinate system. In this case, my guidance to you is you need to select one that's good for your locale, right? In this case, we didn't mess around with it. We're going to stick with the default, right? But that shouldn't be the case for your project. You also want to think about what you want to do in your project. Do you want to measure areas and distances accurately. Well, some projections can do both those things fairly well, but those projections aren't so good at covering broad areas, right? So you have to kind of find that balance. There is a training course that we'll talk about briefly in a few minutes that can guide you through some of that decision making on your own. Or we can have another one of those nice 2-hour-long discussions about coordinate systems. And I'll only give you like 10% of the information that's needed because it can get quite complicated. For example, if you work in Michigan, there's a special coordinate system that you need to know about. Or if you work in Tennessee and you want to represent the whole state instead of just chunks of the state, you have something, you have some decisions to make, right? In this case, I'm going to stick with what everything's in, although I'm going to point out that default will not allow you to accurately calculate areas or distances because it uses degrees as its unit of distance and area. So can anyone tell me how much area is covered by 1 square degree of latitude and longitude at 3 degrees south of the equator? No. I can tell you that there is a 55-mile difference between 1 degree of longitude at the equator versus 1 degree of longitude halfway to the North Pole. But because lines of longitude converge, right? So keep that in mind. So we'll just go with the next. Tolerance is what's the smallest distance between two features. 0.001 meters is far too low for a data set like this, but we'll just go ahead and move forward. One thing I'll mention is if you're going to store very large data sets, you will need to use a configuration keyword. We're talking about like a 1 terabyte data set. This will only happen if you're using huge remotely sensed data sets most likely. But geodatabases can, with some keywords and adjustments, accept data up to that size, about 1 terabyte. All right. The feature class will be created, and then it should add to my table of contents. Nope. Here it is in my example geodatabase, properties, drop it off to the top. And now I have it in here, but it's empty, all right? By the way, these panes can be pinned to the sides so that they only show up when you click on them or mouse over them. They also can be torn out of here and repositioned. I forgot to mention this before. We can snap them to the top or to the left side or the bottom. If we have multiple monitors, we could move them off to a different monitor, etc. I just wanted to point that out here. All right. So I have an empty feature class now. I want to make features from it. I'm going to, again, make sure that I'm zoomed to my reference scale, 1 to 500,000. And then I'm going to go to the Edit tab. Go ahead. You'll notice there's a lot of options here. A couple things to point out. Excuse me, we want to create features here, and so I have my properties. We'll go through that in a second. I can move or split features, or rotate them, reshape them, divide them, etc., all using these tools. I can also change how a feature called snapping works. So snapping is just if there's an existing line, point, area, vertex along a line, so where a line might divide or whatever. My digitizations will snap there, so there's no what we call sliver polygons between things. So like let's say that you're working along at 1 to 500 scale and you have a property like that or a polygon like that, and then you say, okay, I'm going to start here, and snapping works and it's fine, you're going like that, and then you snap here, you still have to clean out that polygon or close it out. And if you accidentally click here when you're making a polygon, this will make more sense in a second, you have this area which is not covered by any polygon. We call that a sliver polygon. And they can happen either with a gap or an overlap, right? Where if you put this here, you would have 2 polygons between this zone. So snapping can be adjusted in this toolbar right here. Right? I'm going to turn on snapping. All right, so in this zone in the Brazilian Amazon, I've got a couple features I might want to digitize. So for example, these areas here, well, let's go with, these ones right here. So there's one called Formida, one called Boca do Lago, another one Barreira Branca, and Carumbé. I'm just going to digitize those. I go ahead and in my edit window, I click on Create Features. Over in the Create Features box that conveniently popped up, I'm going to select my feature class, and I want to make a polygon. I could create a square, but it's going to like literally make me create a square like this, right? And now I have a lousy feature I don't want. I can make sure it's selected by clicking on Select. It's blue on the edge, which means it's selected. I'm going to just hit the delete button. It's gone. Right, so mistakes, especially when you want to delete a feature wholesale, are pretty easy to fix. Right, there's various tools here. I'm going to go with a multifaceted polygon. Now again, I'm going to digitize at 1 to 500,000 scale to keep internal scale consistency across all my data sets. And I'm going to start here with, I guess I said Boca do Lago, right? So we'll start here with Boca do Lago, and I'm going to go ahead and click along on the edge. As you can tell, this is a pretty arduous, annoying process. If I could, and I double click to close out the shape, right? So that's the first one digitized. If I could get back all the hours I've spent doing this, I might be 5 years younger. And then if you notice, we added attributes last time. So in the Edit tab, I'm actually going to click this Attributes button, and it's going to bring up attributes on the side. And at this case, I have farm name null, meaning empty, and owner name null, right? Well, in this case, I forget what it's called again, Boca do Lago. In the farm name, I will enter Boca do Lago, right? And the owner name is not on this map, but I happen to know it is Banco Bamerindas, right? And then I go ahead and click Apply. Now those attributes are saved or linked to that polygon. Since I have snapping on, when I go back to Create Features here, right? Now notice, Create Features is here. Attributes is now a little tab over on the right. Let me go small so that folks in the back can see. Right? I'm going to go to Create Features and select my polygon, and then notice I'm kind of mousing near this, and snapping shouldn't work, or should be working. It should make me snap right to the edge of that already existing feature. But I might have my snapping settings set so that my tolerance is quite high. Maybe I have my snapping tolerance, which would be the distance I have to get close enough to that overlapping point. I'll set it to a much lower number. Oh, and then the other thing I need to turn on is, let's see here. Map units are going to be in degree, pixels. We'll stick with that. This is one disadvantage to working in degrees, decimal degrees, right? Is that you're actually a unit is quite large. Yeah, snapping, I'd have to mess with it a bit, but it'll be a good example for where snapping fails. So if I zoom in on this and I clear my selection here, and then do something like in my symbology here, draw them separate. Well, it'll take too long for me to do here, but I have my two. I can add my attributes in my selected feature here. This is Formiga, right? Formiga, also owned by Banco Bamerindas, right? All right, so we'll stop there because I want to get through how you get to more trainings too, right? But one thing to note is that my edits are not permanent until I've saved them. So let me head back to my map here and explore a little bit, get these in the middle and get back out to 1 to 500,000. So we have our two polygons there. If we want to be able to see through them, I can change the display to be see-through. Right, so they're on there. You can see through them. If I want to save my edits, I must click the Save button, or else it will not be saved. This is to allow like a Control-Z, an undo function. If you make a mistake, you add a vertex before you finalize the shape, the polygon. You can undo that vertex just by hitting Control-Z on your keyboard. Right? So I'll save my edits. Again, this is something that you want to do every time you make significant changes. If there's a crash, you'll lose it all, right? And the software, while it's powerful and nice, does crash from time to time.
I've also noticed in ArcGIS Pro, if you can't do something, if there's for some reason the software won't let you do something, check to make sure you've saved everything. Because there's a lot of times where you actually just have to hit save in order to get another tool to pop up and not be grayed out anymore.
Yeah. So to give an example of that Control-Z functionality, whoops, I have a vertex that's way outside of where I want it to be. I can hit Control-Z and it'll go away, right? All right, so for these two features, now ideally we would go ahead and actually digitize every single feature on this map, add the attributes. 35,000 more gray hairs later, we would have a finalized data set, right? But in the interest of time, I wanted to show you kind of one of the things that you can do with a data set like this. So we have our properties here, right? These two black polygons, and in this database or data set that you can access online, there's actually a map here called land cover. Notice I generated polygons again, or pyramids again. And notice, too, that in the year 2000, this is a classified land cover map. Not classified as in secret, but classified as in grouped according to similar land cover categories. The green areas are forests. And we can actually make measurements about how much forest, for example, is in each one of these polygons if we want, right? Thing to note, when you're working with two different types of data, or any type of data really, polygon data or points data, any function you do will actually only take place or only be done on the thing that you have selected if you have anything selected. So what I mean by that is, let's say I select Formiga, this polygon here, and I do any kind of analysis, the results will only be done to that selected unit, right? So it's a quick way, it can be a quick way to do like subset analyses if you like, right? Before I actually do these summaries, I think it'd be good to go over the tools to show you where to find some, and then we can run some of these as an example. Also in this data set, I have a Landsat scene. So this is a satellite image that covers the exact same area for the exact same date, right? And that's there. It's a multi-band image. If I change the symbology a bit, it'll look a little bit more reasonable. So really green things are forest, less green things are green pastures, basically. And anything that looks burned like this is burned. Or if we look up here, this is an urban area, right? So somewhat true to real colors. Anyway, so we've gone through saving edits, adding attributes, creating new feature classes, georectifying an image. We can edit our data, our feature class data if we want. Again, you would go ahead to the Edit tab, and remember there are some of these, there's this Modify Features thing. And so we can do things like wholesale move a feature. We can also reshape a feature by clicking its vertices and moving them, right? Or we can add a vertex like so in order to more accurately adjust a feature, right? So you can reshape polygons, lines, and points using these Modify Features things. But anyway. So we've made it through section 2. Let's show you where the major tools are in ArcGIS Pro. First off, there's the ready-to-use tools on the Analysis tab. So to use these, you have to have the appropriate data in your table of contents, and you have to have it selected. But if we head over to Analysis, you'll notice there are a variety of tools. The ones I'm talking about that are ready to use are in this, appropriately called Ready to Use, and then also this drop-down menu and some of these other ones which are online tools, and then we'll talk about raster functions as well. So Ready to Use tools, we won't run many of these or any of these, but they include things like coming up with an elevation profile or a view shed. A view shed would be like if we build this 10-foot tree fort here on top of this mountain, how much of the valley can we see? Or I want to build my McMansion on the side of the mountain in this location. Will I be able to see the guy in the valley who has a collection of destroyed cars, right? Hydrology allows you to do hydrologic analysis, like what areas flow into what streams, or what areas are going to be affected by something like an oil spill, right, upstream. And then there's network analysis that are things like logistics or routing. And some examples of some problems that can be solved here would be navigation issues, but also things like if I have an incrossable boundary and I'm trying to site a new firehouse in Terre Haute, where we have plenty of uncrossable boundaries when it comes to emergency service, where would I put the new firehouse, right? These kind of questions can be answered there. Excuse me, within the drop-down menu here, under the Tools tab, there are summary tools, which allow you to summarize attributes within a certain area. There are overlay tools. These used to be called geoprocessing tools, but that's a little bit of a misnomer since almost all of these tools are geoprocessing. Clip acts like a cookie cutter. Intersect sticks two geometries together. So think about it like if you wanted to split Indiana up by county, right? You would intersect an Indiana boundary with county boundaries, and you would end up with a map that has both the boundaries on it, right? Excuse me, union will stick two things together, right, side by side. It will not impose boundaries on the other one. And the spatial join is just comparing features in one layer to the other and joining them together based on location. So that's often used when you want to take the attributes from points and add them to a polygon, for example, right? Some other ones include what we would consider geostatistics here, analyzing patterns. So kernel density would be a density of something per square unit, for example. And then these are actually hotspot or spatial clustering analyses, and empirical Bayesian kriging is spatial prediction based on past value. Proximity features include building buffers. This is often the case for site suitability analysis. You want to make a new vineyard. You want it to be within 10 miles of a highway, so you find all the land that's within 10 miles of a highway using a buffer. So you have a highway feature, you say, build this buffer out 10 miles to either side of the highway, right, for example. Near is going to pick the feature nearest to an input feature, and you can actually generate what's called a near table, which will tell you how far away, sort of like the old highway atlas. You had like, okay, I'm going to go find St. Louis, I'm going to find Chicago, and that's the distance between the two. You could generate using the near table. And then manage data allows you to do some appending of data sets, adding things on the end, right? Dissolving features based on an attribute. So in that example where we combined counties with Indiana, if there was an attribute in there that said this place is in Indiana, right, we could dissolve all those county boundaries away based on attribute, right, to simplify our data set. Merge is going to stick together data sets again, and then you can sort or calculate fields, etc.
I would encourage you to, if you have any students that are interested in this kind of work in your program, have them try out buffer, near, hotspot. These are all very simple tools to use, and they get a lot out of it too. So it's analytical power.
Yeah, and like optimized hotspot analysis will output a report that actually will teach you more about statistics than your statistics class did, sort of. I'm joking a little bit. I'm teaching a stats class this semester, but it will guide you through the interpretation. You don't have to have taken a college-level stats class to actually get useful, valid information out of it, provided you're thinking clearly about the hypothesis you're testing, right? And then I wanted to point out that some of these require network connection. So network analysis, this requires that you're signed in to the service, which you'll get to do once I send you the invitation to join our organization. Business analysis is the same thing. So it'll give you suitability analysis, etc. These are going to open up wizards along the side here that you can walk through to do these analyses. And oftentimes they will include canned data, so you don't have to do that. Now again, this tool is not licensed because I don't need to use business analyst in my research, so I haven't allocated myself a license. But Jim.
What is Esri Business Analyst? It's plugged in here now?
Yes, the website that they have still exists.
You can get it all here?
Yeah, you can get some of it here, not all of it here. They'll probably eventually have all of it here. Thing to note with some of the business analysts, and there's also a tool called Community Analyst, the licensing agreement we have with Esri allows us to do some things but not other things with those data. So I can give you a copy of the license and send you to Katie to talk about the legal aspects of using it. But for example, you couldn't use it to help a local business pick a location and charge them for it, for example, right? Like, so you couldn't run consultancy using business analysts unless you pay Esri more money. Right. So use cases, you have to be careful in some situations. Jim?
And then they also had the empirical Bayesian kriging, but they didn't have other options. Did they get rid of the other options, or are they in there somewhere?
They're in there. I'll show you how to get those. Okay. So if you click on Geostatistical Analyst, there's a lot of kriging options here. Kriging and co-kriging is not the same kriging you're probably used to running. So there's a lot of different geostatistical models here. Unless you're trying to interpolate or predict things over space using multiple variables, you probably won't be in Geostatistical Analyst. Jim, you might. Some of you also may have this need, but it's less common at the beginner level, depending on what your goals are. Okay, so those are some of the tools. I also wanted to point out that there are these raster functions now in ArcGIS Pro. If you have data like this satellite image in the background, you can run a variety of tools if you have the right data in there. So it used to be NDVI was sort of which is a vegetation index, sort of a complicated thing to run, or maybe figuring out how to I don't know, run a distance tool, right? Cost allocation or something was fairly complicated. Now you can run these temporarily even, so that you have like a layer output that you don't have to save locally to disk. So if I were to do NDVI with my Landsat image, my visible band, mosaic, sorry. So my visible band, what is it? Near infrared, or visible band's 3, infrared band is 4. I can create a new layer. It happens very quickly, and it gives me colorized NDVI. In this case, most of the features in this area have some vegetation, right? Because it's the Amazon. But these deep green areas are higher vegetation index than the lighter green areas, right? So there are a lot of raster functions that are kind of stuck together in here. And then finally, what Jim was asking about is actually, it's like, well, I knew that there was kriging, but I don't really want to use empirical Bayesian kriging, which is a totally different method, although it involves kriging in the end. You can find all kinds of other tools by clicking on this Tools button, and it'll bring up this geoprocessing search here on the right-hand side. This is similar to the Search tab in ArcMap. You can type in a keyword. So if I wanted to do kriging, I can type in kriging, and I get a variety of options, some of which are the classics, right? Kriging here, both of these are the same. This one requires a spatial analyst license, this one a 3D analyst license. When I invite you to join ISU organization, you will have access to both. So it depends if you like to pick the first thing on the menu preferentially or the second thing. It's up to you. There are other options too that might be new, like empirical Bayesian kriging. That's been around a while, but moving window kriging is fairly new in ArcGIS. Right? Same thing if you're like, well, I want to know, I have these points I digitized from a map. I want to know what the distance from city to city might be, or from the main city to all the other cities might be. You can put in just the word distance and start looking at what these tools actually do. So in this case, cost distance, probably not. Accumulative cost distance, no. Flow distance, no. Standard distance is, notice I'm hovering over it, I can read more, right? It says the degree to which features are concentrated or dispersed, no. Oh, Euclidean distance, how close something is, right? So I might say, well, that looks familiar, or that looks possible. I want to check it out. You click on the tool, and here's that question mark that I was talking about. You want to learn more about how this tool works and what it does? You go ahead and click on the question mark in the upper right-hand corner of the tool, and it will, if you mouse over it, it will bring up a little description, usually with some visuals. If you click on it like I did here, after a moment or two, it will open up online help. You can download and install offline help if you like. It tells you all about this, including, and I'd recommend if you're not familiar with the tool or you're getting errors, that you read the usage area pretty in detail. Because anything that could mess the tool up or create an error is likely to be listed here, okay? It'll tell you the syntax and what each one of these parts of the tool are, right? These correspond, right? In source data corresponds with input raster or source data, right? And it'll help you understand what the tool's doing and what each one of these parameters are. Finally, I was going to mention this towards the end, but you can automate processing using Python as a scripting language. And each one of these tools, with almost no exceptions, will have an example in Python if you're into either creating your own tools to process data or trying to learn Python for geographic information systems work. All right. Okay, other tools that you should be aware of. I mentioned Python as a programming language and a way to automate processing. It's something that I spent about 8 months learning myself a couple years ago, and it has saved me at least 1.5 years of my life toiling away with GIS at this point, I would guess, but I'm not sure. I haven't actually empirically measured it. Python is definitely a thing you can use. There's also, if you don't feel like learning a programming language, but you know you have a complicated workflow that you have to work through, there is something called Model Builder here, which will allow you to create your own custom tools in an interactive environment. So in this case, we can drag and drop from our view data in here that we want to work with. We can drag and drop tools from our list that we might want to work with. We can connect these to each other and actually create a step-by-step analysis workflow that we can run, save it, even to document our workflow process. It's pretty clever, and even can include iteration through multiple feature classes or layers or selections, right? So if you've got a big project, you can put in a bit of time to create a nice model, and it will run through the same way every time. Let's see here. And then the other thing I wanted to mention is that with these geoprocessing tools that you find by going to the tools box and searching for something, right? I'll go back to Euclidean distance. On most of these, you can right-click them and go to batch, and it will bring up a way to create a batch process where you do the same thing to a whole bunch of different layers all at once, right? So, for example, if I wanted to make a Euclidean distance file where I figured out the maximum distance or whatever, I can go through here and select all of the features or all of the things that I want it to do, and then click go and go to bed. And all night long, my computer will process, and hopefully by the morning, all of my analysis would be done, or at least that step of my analysis will be done. So batch processing is another way to save time. Anything else in that? This is a whirlwind overview of the tools because we could sit here for years before we work through how every one of these tools and use cases work. All right, I know by now you want to go to sleep, and we've got about 20 minutes left. So the two big important things here, the next part is actually the most important thing maybe from your perspective is how do I actually dig in and do more of this? When I send you the invitation to ISU's organization, and by the way, when I send this, you should check your spam folder because sometimes it does go there. It's going to come from ESRI Incorporated, ESRI. It will say, like, Steve Aldrich has invited you to join his organization. I do not think I own Indiana State University. It's just the language they use. So you're going to join Indiana State University, even though you're already a member of Indiana State University, and you'll create an account and you'll have access to this stuff. So the first thing I wanted to show you is actually the training.esri.com site. You can find this by searching in Google, like training ESRI. And it'll bring you here if you, excuse me, if you sign in, it'll show you what's available to you. You have access to most online trainings here. So if we go to the catalog, I'll show you kind of how you can search this. Come on, course catalog. Here we go. You can search it either browsing by topic, saying, well, I'm just getting started with GIS, or I'm really interested in scripting and development, or perhaps analytics, right? You can choose these. And it will filter the courses based on kind of beginner level things. Now, there's a lot of stuff up here. Some of these are web courses. Essentially, you log in, they'll have a little video, they'll take you step by step on how to do things. And believe it or not, I do a couple of these every year just to either learn new tools or keep up with changes to existing tools. Or just to, if I'm considering assigning one of my students one of these things, just to see what it's about. There are training seminars. These are going to be more like videos that you watch that show you how to do things. And then there's instructor-led. Now, instructor-led you would have to pay for, right? They're not included with our maintenance. I know, it's a bummer. They usually, I think they do some of these in the Indianapolis area. I've never taken one, but I've heard they are very effective, although they are somewhat expensive, right? But if you have 3 days to dedicate and some money to do it, they are actually pretty useful. And I think we get a discount being a site license holder. Let's see, there are a couple other things in here. There are like video tutorial, like overview videos and things like that. But anything in here that says requires maintenance, you can use once you have a login.
Is there such a thing like, ArcGIS Pro for Dummies or some book like that? Or?
There are books too, although Esri's moved with their own products to mainly an online one. I would recommend, although Dr. Obermeyer, you use some too, right? You probably have some good feedback. I really like the Mastering ArcGIS series of books, ArcGIS Pro. That's a pretty good one. It comes like in a binder format or a spiral bound kind of format. I think it's by I think Marie Price. It's a very good one. What do you use, Nancy?
I've used ESRI products in general.
So, or like getting to know ArcGIS Pro is probably, if they have one for Pro, a good one.
And the thing that I like about that is that it has its own data set included with it, so it kind of gives you a think about how to do that. And if you're, for example, if you're doing something in the social sciences, there's a lot of data available through here in Indiana map, but also the U.S. You can get all for free U.S. Census Bureau data down to the census tract level. Also, you can overlay that on county maps, on state size maps. Totally, the amount. This is one of the things that I think has really just blossomed over the years in GIS is the amount of data that is freely available, and particularly in the more developed countries. There's a lot of data available, not just on the environment and the physical geography, but also on location of people, their characteristics, and so on. There's also other kinds of shared data sets that are also useful as well. But the nice thing about when you have data from the U.S. Census Bureau, it is highly reputable, so you don't have to worry, about that's as good as it gets for data here in the United States.
It's not going to be corrupt or inaccurate.
Free download.
Yeah. That was kind of one of the next things that we wanted to talk about, so thanks for bringing it up. There are a variety of really high quality data sources for free data, especially if you're interested in U.S. locations, some Latin American locations, a couple other places around the world, but it really depends on the public data model. So here in the US, our public data model is mainly you pay for reproduction costs, not for a portion of the cost of collection. That's not the case elsewhere in the world, especially in European nations and in former European colonies, although Latin America might be a little bit of an exception. So like in the United Kingdom and in mainland Europe, if you want to get access to government data, in many cases, if it's not remotely sensed data, in many cases you have to pay not only for the cost of getting you a copy of it, right, but also a portion of the original cost of making those data, which means that data that we get for free here may cost many tens of thousands of dollars even, depending on the scale. So we're actually pretty lucky to live in a place with open data access in a lot of cases. So in Indiana, if you're interested in doing a project here, there are 2 data sources that have really high quality data. One is Indiana Map. If you go to indianamap.org, the Data and Resources button here, and then choose one of these. I usually go to the layer gallery, but you can interact with this through an online map. There's demographics, including prepackaged census data, environmental data, imagery, including high-resolution air photographs, LiDAR data if you want to work in 3D, using point clouds, all sorts of stuff, right? If you want imagery data, most of the imagery data is actually available at gis.iu.edu, at the Indiana Spatial Data Portal. Again, these are free, they are high quality, they're packaged. When you create an order, it may take a little while for them to get it to you because they're literally, there's a tape pulling robot that pulls the data backup tape and puts it in a reader for you over there in Bloomington. But it's really high quality data about Indiana. If you're interested in working more in the United States still, but kind of more broadly outside of Indiana, each state, almost every state, has some form of geographic data portal. Some states like Indiana are really good at that. Some states used to be good but are not as good today. I'm going to call out Michigan in this regard. Some states are way behind, Illinois being one of them. So depending on where you work, you may get good state level data, you may not. But at the national level, the national map has a lot of this stored in one easily accessible place. The Census Bureau also has geographic data you can download. So you download the geographic data and then the tabular data and then create connections between the two in ArcGIS Pro. Most of the federal agencies, especially the ones that deal domestically, have GIS data, like Fish and Wildlife Service or the Park Service, right? Department of Interior in general will have on each of its agency sites in various places geographic data. And then even data.gov will have spatial data in the United States. If you're interested in imagery data, there are 2 sources that I'd like to kind of point out. One is Earth Explorer. Earth Explorer is a USGS site. This is where you can get most Earth observing satellite data that NASA and even the ESA and some of the other European partners make available for free or low cost. You have to create an account, but you can access all kinds of imagery data at this portal. Another similar platform, same data sets, just a different interface and interacting with it is called Glovis, the global visualizer, right? And then, if you're interested in working outside of the United States, it just depends, right? So I work in Brazil. Brazil has very good federal level data access modeled after the United States. I have colleagues who work just not too far away in Colombia, and it's a totally different story, right? Data like census data are very difficult to come by, mainly due to the longstanding kind of civil war conflict that's happened there, right? So it sort of depends. If you want to work in China, good luck, right? Because spatial data are almost invariably classified as a state secret. So, it sort of depends on where you want to work and what data are available. That said, you can often get basic data using processing satellite imagery, either visually or through some algorithms to get some of that base data for almost anywhere on Earth. Finally, there are private data providers that will allow academics a certain allocation of high-resolution satellite data if you're into this, if you request an account. So one of these is the Planet Imagery Company. So they run a couple of different satellite platforms, but they're into microsatellites. So they launch these microsatellites in orbit, and after 2-year period or so, they burn up in the atmosphere and they just launch more. It's a little bit wasteful, but they have 3 meter data for most places on Earth on a very reliable, on a fairly good repeat cycle. And you can ask for something like 1,800 square kilometers of data a month or something. So that's another option if you want to use high resolution data for an outside the US place. Dr. Obermeyer is completely correct. The amount of data that's freely available is mind-boggling. And there's a good chance that with some creativity you can do a GIS project almost anywhere, covering almost any time since at least the mid-1980s. And if you use some of the techniques we talked about with georectification and digitization, you can go back in time almost as far as you can go. So one example of a GIS project I did a number of years ago was to look at historical maps of the Brazilian Amazon showing anthropogenic soils all the way back to the 1520s, right? And you can't exactly link the location, but you can find pretty close to where those locations were, and constructed the first, me and a co-author, she was the lead author, created the first map, comprehensive map of Amazon dark earth soils that was ever done, right? There were a lot of regional maps. So you can use these techniques to go back in time quite a long way. It's just kind of limited by your time, creativity, and what data you can scrounge up that you can turn into maps. In the last couple of minutes, I think Dr. Bedijo wanted to show 3D, ArcGIS and 3D. You want to plug in here?
Yeah, I'll plug in there. A few comments, and I'll make these few statements here, and I know at 3 o'clock and people probably need to get going. I'll start in and showing a few things, but if you need to go ahead. But if you want to stick around, I can continue showing what I've been doing. But my comments really are for new users. How many people are new to ArcGIS or just want to maybe incorporate it? But my advice would be stick to number 1, number 2, and really get to know the interface first. Learn how to create some feature classes, manipulate data, maybe load in attribute tables, and then start in on 3 once you feel comfortable with 1 and 2 here on the little handout we've got. That's kind of my 2 cents there. And then also, I've been working with GIS for about 11 years now, and ArcGIS Pro is brand new to me. I've been using the training that they have in ESRI, and that's kind of how I've learned in the last 6 months how to use this software. So if you're trying to transition from ArcMap 10 point whatever to ArcGIS Pro, my advice is maybe dabble into some of that training. You'll get some of the locations where tools are and the nomenclature down, and then you'll probably just be able to get going if you already have a little bit of GIS experience. I just wanted to say those couple of things before I put something here.
Yeah, this would be a good place to start in the tutorials. Get started with ArcGIS Pro. It says it's 3 hours. If you pay attention and do it, it's probably more like 1 hour and 20 minutes. It'll come with its own bundled data, and there'll be like a little video. There'll be some how-to, like step-by-steps. And at the end, you can actually download a certificate and stick it in the FAD, say, learn GIS that way if you really want.
Okay, I don't have much space here for my mouse, but I'll make it try to work. So here's ArcGIS Pro's interface, and I'm just going to show you a little bit about a project I work on in Peru, in southern Peru. Kind of give you that location there. We do regional survey. I'm an archaeologist, and often what I do is I look for archaeological sites and map them, put them in a GIS so that we can then later analyze these archaeological sites within a region. This was the region of survey outlined in black here, and each of these little black triangles are each of the sites we found this past summer, or at least documented. They've already been found by many people before, but we actually did go in and map them. One of them I had kind of prepared the imagery that we put together. For these sites, I had to create these little polygons using that create polygons or create feature class steps that we were talking about before. Here's where I was able to load in an attribute and label it with those attributes. But part of our research was to fly a drone overhead at these sites and get a 3D map, 3D data of the surface, but also get this high quality imagery. So I pulled together one of them here for you, and you can start to see some of that imagery come together. There's a truck for some scale, and an Inca site with some of the buildings, and you can see the floor plan. It's very heavy data because it is high resolution, but you can zoom in and get down to a much tighter resolution here. We can see each individual rock, and you can actually go in and use measure tools to measure the widths of these walls, the lengths. But what's really great about this imagery is now we can start the process of, again, just creating a feature class over each and every one of these buildings and loading in the visible, observable attributes that you can see right here in the ortho imagery. So this is a complex project in terms of like data collection, but really on the back end, you know, intro GIS students or even someone who just has a little bit of knowledge would be able to help out in, you know, digitizing all these features, loading them up with attributes, and then we can get into some of those more advanced tools to understand the history in this area. Underneath this, I do have a digital surface model, which is just a model of the surface of the Earth in terms of elevation, you know, rises and lows. But it's just kind of flat, and you can't really tell any of that definition underneath. You can't see that relief. So using this, let's go to imagery, and we have our raster functions. If I clicked here, my raster functions comes up over here, is what Dr. Aldridge was showing you. Under surface, there's a thing called hill shade. It helps you visualize that relief. If you use that tool, you can then make it kind of pop out so you can see better some of those structures. So if you have a nice sharp digital elevation model or digital surface model, you use your hill shade tool, then you can see things pop up and on the surface in terms of the topography. Here, I can use this in concert with the image back and forth to really draw in where those structures would go. And so that swipe tool that he was showing earlier, truly useful. You just go to making sure that that ortho image is actually selected there, hit appearance, click on swipe, maybe. Let me go back. Sure. You can see where the outline of a building has, okay, there's another platform above that, so yep, it follows. I do have a pattern in the rocks. Up here, these don't look like much in the imagery itself. If I zoom into them and I explore a little bit, look at the difference there. All these places have little flat areas. So using a simple tool in the raster function, plus getting that ortho imagery and be able to swipe it back and forth, digitizing it, we can start to create something powerful for a regional analysis. Now the challenge is I have to get my students to do this for every single place where I have imagery, which in each of these little green rectangles I have UAV data, and they have to go in and draw every single structure. I'm already counting to about 1,500 structures that they have to go digitize, load in all the attributes for construction material, construction technique, lengths, widths, heights, all that stuff. But again, to help them out, all I had to do was come in and create a feature class and start flagging things that I notice in the imagery, things that look suspicious that they need to then go in, look at, compare to the DSM, and then start actually making. Yeah, this isn't one of them. I had to take away all my ortho imagery because it's so heavy that you have to do it bit by bit. Yeah.
Have you thought about crowdsourcing that?
I don't know. I don't even know where to start for that, but that would be a great idea.
Zooniverse is like a pretty easy load up. I've been looking at it.
What is it called?
Zooniverse?
Zooniverse?
Yeah.
Nice. I would feel comfortable crowdsourcing the drawing of it, but making sure that there's some sort of quality control in terms of like loading the attributes in a very systematic way. Because that's the other thing, we're working with databases here. We have to make sure things are standardized for those analyses to come out right. But, yeah, so that's one of them. And the other one is the 3D function here in ArcGIS. This is another project who Dr. Drew was actually part of this project of relocating a cemetery from one place in Indianapolis to another place and doing it while recording everything in 3D and then putting it back in another location. So here we are, Indianapolis. Here's the plot where the cemetery was going to go, and which it did go. And we went out, say last semester, and actually flew this so that we could get a nice orthophoto of the new cemetery. So here we have a nice orthophoto. We can zoom in, see kind of the quality of the imagery here, each and every headstone. We can put our digital surface model underneath that, where we see the differences in height. And of course, we're working with structures that are hard, headstones. So you can see very clearly the change in elevation there. And then using that same hillshade tool, pop that in, and it looks more like a piece of tinfoil with stuff underneath, and it just makes that shape of the headstones there. Altogether, not difficult to make using drone technology nowadays. But then, this is where ArcGIS Pro comes in handy for 3D data, if it loads up.
I can do it. I get the blue ring of doom down there.
All right, here we go. So what I have here are two different windows. This one is a scene, this one is a map, and the scene is capable of actually manipulating the 3D model itself. So here in the scene, I can see my headstones now from the side. But at the same time, over here in the map view, it's just showing me the plan view of exactly what I'm seeing over in the 3D view. So being able to manipulate these things together is kind of I don't know, it's definitely an advantage now. We have other data sets here that we're planning on using this for, so that we can see even underneath the ground, which is something else that ArcGIS Pro can work with, is seeing, let's say, earthquake data in the subsurface and doing an analysis of those things. So just a couple examples of kind of the powerful tools that this software has, and things you can do that are very basic skills then apply to data sets like this that can actually really get to some powerful conclusions. So that's pretty much what I've got. Yeah?
How long does a drone have to take pictures over a site like that to get that kind of resolution data?
For this, really getting each and every headstone, we were out there for a morning, wouldn't you say? Yeah. We were out there for a morning. Yeah. Yeah, in the morning we were just kind of preparing everything. We put down our ground control points, which was little aerial targets. You can see one there in the picture. And then once these are down, and you use some sort of high precision GPS, differential GPS, or total station, fly the drone overhead, and then the rest of it is post-processing, rendering the image. And then if I was going to try to create a data set to get back that just had the polygons of each footprint of each headstone, then I've got to do that too.
Yeah, for an area that size, like 20-minute flight, maybe?
Super fast, yeah.
And that flight, it's taking individual images and then mosaics together, right?
Mm-hmm. Yeah, I didn't want to get into that too much just for time constraints, but the method we're using here to create these 3D images and these maps is structure from motion photogrammetry. And that's just that science of being able to take multiple 2D images of an object, a feature, architecture, or even a full landscape, putting it in the computer. It uses all these processes and algorithms to recalculate the distances and angles and reconstitute all that geometry so that you have a 3D representation of the pictures that you are taking. You just have to make sure you have enough pictures of all of those angles. So we do this here at the landscape scale, which applies here to the GIS, and we can put it in here and do the analysis, but we can also do objects itself. Altogether, we're looking at documenting 3D space. To me, it's all one and the same, but what's really cool is what you can now do in a GIS with 3D models on a map. I just did a project where we were supposed to document a bridge going from one end to the other. We flew the drone, we took pictures from underneath and in the water underneath, reconstructed the bridge digitally, and then placed it in ArcMap. And it's really cool to see from one end of the DEM and ArcMap, it actually disconnect from one side to the other, the 3D asset.
So some of these tools to capture data like this will be available in the lab renovation that's been slightly disrupting our meeting here. They're working on renovating this lab into a 3D visualization lab and collaboration space. We'll have classroom capabilities, but also a lot of the tools that we're showing you here, including VR and 3D printing as well. So I think Dr. Bedijo brought in some 3D models that have been printed back there that come from landscape captures using some of these techniques. Right? So GIS can eventually make it into an actual physical object if that's what it would be.
And that might be something you're thinking about with your classes. You want to create some sort of 3D surface or an object, print it out. We'll have the printers here in this visualization classroom. This equipment that can create these exact maps is going to be here in this classroom as well. So, yeah.
How many will the classrooms seat?
I think 26.
Yep.
26.
Yep, and we have a large format display going on over here.
Well, That's kind of all we had. I know it's a huge download. If you have specific questions or you want to talk about your own implementation in GIS, I think, I don't want to volunteer Alex's time, but I think either of us would probably be happy to talk to you about it. And as I mentioned before, we're not the only people who do geospatial work in the department. Dr. Obermeyer, who was here for a little while, does, Dr. Berta does, and Dr. Wang does as well. And then there are plenty others who think spatially who can probably help you through that as well. So I will, in the next 24 hours, get you invitations and licenses. So what you need to do if you want to participate in that is accept the invitation and perhaps create an account with ESRI if you don't have one already. If you click the link in the email that ESRI sends you inviting you to our organization, you will have access to the training site and you'll be able to sign in when you install ArcGIS Pro. I'll also, in an email, send each of you ArcGIS Pro download and installation instructions, right? And the link to download the stuff that I showed today in class. So it's all along in the video. And finally, the link on YouTube to the video and audio. So I guess thanks for coming.
One other question.
Yeah.
I can download it to my office PC. Can I also download it to a PC I have at home, or am I getting only one shot?
You can. Because ESRI's moved to a named user licensing model for ArcGIS Pro, you can install it on a whole bunch of computers. But if you leave your office computer signed in and go home, you won't be able, or vice versa, you won't be able to use it on your home computer or office computer. Right? So you can only use it on one computer at a time. So just remember to sign out. But yeah, you can use it on multiple machines.
Kind of counter to that, if I download it on one machine in my lab, can I use it, then my student can come in and log in and use it separately?
Yep. And if it's a university-owned computer, we can give you a node-locked license. So that would be one that always works, like we have going on in the lab here. There are two caveats about that. One, you will need to get a new license update every February. And two, I wouldn't do it until after mid-February this year, because we can give you one now, but it will be bad in 3 weeks. Yeah. All right, well,
thank you, John.
stick around if you want, but thanks a lot. And if you haven't signed in, please do, because that's the only way I'm going to know for sure to send you info on how to use this stuff.
Let me get that out of the way.
That's fine.
And feel free to handle the 3D objects in the back.